Today, we want to discuss Twist Bioscience and the potential for disruption coming from synthetic biology, in particular the Twist Bioscience business. This is the Not Even Wrong podcast. It's November 24th, 2020. This is Krim Delco. Since the last update on November 22nd, we're up 34%. The market's up 2.2%. For the year, we're up 290%. The market's up 12%. That means that we are outperforming by 278%. So if you put $100 in Orange Capital Partners at January 1st, 2020, you would have $390 by now and $112 if you had done the same thing with the S&P 500. We've been discussing the innovator's dilemma, the first 7 chapters. Chapter 7 in particular talks about the need to start small and build an innovation stack around the new technology. So we want to discuss Twist Bioscience. Twist is one of our positions. It's part of our CRISPR index, but due to the extreme strong performance of the stock, the position has now grown quite substantially. It's roughly 5% of the portfolio as of NAV today, so it's pretty large relative to other positions. For example, Microsoft is a little bit larger. And then, of course, Tesla is by far the largest position, but we have a decent sized position in this stock, and it's an interesting situation because I think it's a good example of how to deal with disruptive innovation and how to think about it fundamentally. So let's first define what disruptive innovation is using Clayton Christensen's framework, and then apply it to Twist Bioscience. So disruptive innovation is a new technology, a new process, a new product, a new idea, a new instantiation of knowledge that is transformed into products and services that are either enabling a completely new market or that are attacking a market from below. So, for example, in Christensen's example, one of the new markets was scrap steel, which was enabling the mini mills to make different kinds of steel, low-end steel. So it wasn't a completely new market, but it was low-end steel, and then they grew slowly into the mainstream and higher-end markets, and therefore started to disrupt the existing steel manufacturers. So now let's talk about Twist Bioscience. The business of Twist Bioscience, basically 4 businesses. One is synthetic DNA. One is new generation sequencing. Then we have biopharma, and we have DNA data storage. So these are 4 businesses. 2 of them are large. 2 are large right now, but relatively mature from the perspective of Twist Bioscience. And 2 of them are completely new, even from the perspective of Twist Bioscience. So the 2 more established businesses are the synthetic biology business and the new generation sequencing, NGS. So synthetic biology is, imagine you want to have a synthetic DNA, you order it, and they synthesize it for you. This is fairly commoditized. In talking to industry participants, I think it's been widely reported that that business is fairly commoditized. So what Twist Bioscience has done, though, is build an innovation stack around that business by enabling e-commerce buying, so you can order these things online. They are pretty much automated, produced. The channel is relatively innovative, and I think that's one of the advantages of Twist Bioscience. In the NGS, Twist Bioscience has a couple of advantages, and I think one of the biggest advantages of Twist Bioscience, they keep saying, is the speed, scale, flexibility. So those are, I would say, not necessarily disruptive characteristics. Those are more sustaining characteristics. On the biopharma side, which is a kind of a new emerging market for Twist Bioscience, the biopharma side is, think about it this way: you identify antibodies, and then you produce them and you deliver them to pharmaceuticals. So what that is a library of antibodies. So it's kind of like you create DNA that then synthesizes proteins, creates enzymes, creates things that could attack certain pathogens, or in plain English, you find attacks against diseases. And those attacks are DNA-based, synthetic, organisms. That's the business. On the DNA storage side, this is storing data in DNA. I want to talk about this specifically because to me, this one seems like the most potential disruption of all of them. So I think, again, the first two businesses which are relatively stable are the synthetic DNA business and the NGS. I would say there, Twist Bioscience is leading by scale, by channel, by market share, by things like that. There's certainly a lot of innovation there, and there's also a growing market. So this is more, I would consider that market comparable to the chip market, the CPU market, the memory market. So those are not necessarily differentiated businesses in the sense that Twist is very unique there, but Twist has certainly, on the one hand, an advantage by being fast, flexible, fast turnaround times, low cost production. They have, by the way, I forgot to say, of course, the reason Twist even exists is because they have developed a technology to create synthetic DNA on chip. What that exactly means is now beyond this episode, but I just want to say that they found a way to make something which is not very hard to do in the lab at scale much cheaper. This is the main innovation. So I would say it's a sustaining, maybe a radical innovation, but it's still not disruptive in a sense like disruptive that it's completely opening new markets. It is opening new markets because people that couldn't afford, that couldn't actually do synthetic biology in the past now can do synthetic biology because it is a lot lower cost. On the NGS side, same thing. So I would say those two businesses are opening up new markets, enabling new participants, enabling, let's say, labs that maybe couldn't afford at scale DNA and derivatives of DNA. Those types of customers have now the potential. So there's a growing market. So I would consider Twist comparable to, let's say, when the solid state drives came up, when solid state storage, flash storage came up, and the market started growing first in specific applications, and the costs started coming down, and then more and more people. So there's a lot of the adoption curve, I would say, is accelerating thanks to innovations, sustaining innovations that Twist is doing. Now, more importantly, I think the two, more disruptive businesses, one is the biopharma side, biopharma, where Twist is building libraries of DNA of antibodies. And this is, I think, where there's a huge potential for a game changer for, I would say, a disruptive market. Because if you think about pharma in the past, way past, before genetics have become sort of an integral part of pharma, has been more of a try and error serendipity type business. And what Twist is doing, and this is why we're so excited about Twist Biosciences, Twist is building a library, Twist is building a synthetic library of potential antibodies that could be used to attack all kinds of different illnesses, namely one of them, of course, COVID-19, but there's a lot more than that, of course. And the point here is that you have data, you have libraries, and you can start doing comparative statistics, you can do analytics, you can do algorithms, you can start incorporating this data into more algorithmic approaches towards antibody research. And then, of course, the antibody research is part of the pharmaceutical supply chain, and the pharmaceutical supply chain being, in the end, delivering solutions for illnesses. This is, I would say, another disruptive technology in a sense that it is opening up new markets, but it's not disruptive in a sense of Clayton Christensen, because I think everybody understands the power of this technology. This is not something that the incumbents are sleeping. There are no incumbents, actually. So this is more like the transistor or CRISPR, where you really have a new way of doing things and everybody's excited about it. So now the point is somebody has to actually implement it, make it palatable, make it algorithmitable, make it programmable. All these things are done by Twist. So Twist is building, I think, a platform here that can have enormous potential. And this explains why we're having a company with 100 million in revenue at 5 billion market cap. Of course, this is, I would say, 60-70% of the valuation. Now, the DNA storage, to me, that is the big 800-pound gorilla here. Right now, this sounds like science fiction. Netflix stored a movie on DNA. you can say, who cares, and it's fun and this and that. But of course, we're talking here about absolutely disruptive technology in the sense that now we're talking about a new way of storing data. Data is being stored in typically memory chips that Micron is producing and others, and the storage is using transistors. DNA has a very different profile. DNA has, first and foremost, longevity. Nature has developed DNA as data storage, so of course it has longevity, millions of years. It is very difficult to do. It's expensive. It doesn't have the scale and all these things that the transistor-based memory has. So of course we're looking at an emerging market here. And the question now is, how can this market, if at all, emerge? How can it disrupt the existing memory market? And I think this is a perfect example of the necessity of building a small organization, of starting to build an innovation stack around potential solutions that DNA storage could build. For example, data that has to have very, very longevity, a lot of longevity, and that has to be incredibly small. Data that has to be very, very secret, that cannot be corrupted. So I'm thinking of things like security applications in the form of CIA stuff, Secret Service stuff, generally just data that cannot be corrupted, data that has to be incredibly safe from just physical corruption, from hackers. And I think there is potentially a market, a small market, but it's a market. And it can be used to start growing an innovation stack around DNA storage. I could imagine 10 years from now, DNA storage being a potential threat to flash memory and other types of storage, and maybe being used in cars and whatnot. I don't want to go that far. This is just a perfect example of a technology that right now, if I'm a salesperson at Micron, if I'm a salesperson at Hisense, some of these storage giants, these companies will potentially just say, yeah, this is a nice to have. I mean, come on, this is R&D, this is science fiction, who cares? We're not going to spend too much time with it. Let's put some interns or some postgrads to write some reports, that kind of thing. They're not going to take it too seriously. And again, this is Clayton Christensen par excellence, in a sense. I don't think that these people are neglecting the market. They're not lazy. They're not complacent. None of that. They're not interested, because DNA storage right now is a low margin, low absolute dollar type business, no matter how you look at it. But it's time to look at it right now. Twist is doing it, and they have potential to start building an innovation stack around this particular technology. And that can be, who knows, that can be a multi-billion-dollar market in 5 to 10 years. This is the potential of disruption. This is exactly what disruption is. And I think, therefore, that's why Twist is such an interesting stock. Again, it's a $100 million company, $5 billion market cap. Clearly, the valuation is way out of control if you look at it in any kind of generic valuation type model. But if you look at it from a disruption model, I think it's actually even undervalued. And I think the optionality in this company is tremendous, and we're very happy to own the stock, and we potentially will even add more. Thank you.